Hi, I'm Thomas Hope, and this is my submission for scripting and dynamics on swarm hunting behavior. To get the simulation up and running, open a new scene in Maya, load and run the script, then create a new expression calling the runBoids function. The core functionality of the script is based on Craig Reynolds' Boids, where he described the rules of separation, alignment, and cohesion. As I researched how to implement these rules, I found there were a number of different approaches of varying complexity. As I wanted the agents to be able to act appropriately for a wide range of scenarios, I chose to keep the implementation of the rules as flexible as possible, allowing separation, alignment, and cohesion independent variables for range and weighting, and a separate weighting for target seeking. By going to the Settings tab, the user is able to vary the rules of the simulation as it is running, and see how different combinations affect the behavior of the group. The simulation allows for a dynamic number of agents. During testing, I was able to get up to 50 agents running in real time. Although the script is intended for real-time playback, even more agents can be added, provided the user is willing to view them at a lower frame rate. Here you can see 100 agents being run at a lower frame rate. Then the user moves the timeline to view the simulation in something closer to real time. Flocking can be disabled, where agents will start to follow random individual paths. Or they can be set to target other objects. I was particularly pleased with the user interface created for this project. An effort was made to keep all the relevant controls in a unified window, and to enable and disable controls depending on the current state of the simulation. This helps to avoid errors and direct the user without explicit instructions. Care was also taken to handle as many corner cases as possible, such as what happens when an object is deleted from the scene, or when the timeline is moved between runs of the simulation. Flocking is often cited as an example of emergent behavior, which is described as the behavior of a system arising from the relationship between its parts. While the exact result of an emergent behavior is unpredictable, therein lying its value, there are certain types of behavior that are expected, such as the general motion of the group. When I started combining different rules, however, I came across types of behavior that I hadn't anticipated. When a group of agents is given a target, and flocking is disabled, they appear to be in competition, clambering over each other in an effort to reach it. But when both targeting and flocking are enabled, it appears as if there is cooperation among the agents. Another example was after I implemented targeting. I tried setting one of the agents as the target. This gave the appearance of the target agent being the leader of the group. The target simply carried on its own path, with all the other agents following. This recombination of existing rules to create new group personalities would be extremely useful for games, as there is both a production time and performance constraint. Allowing designers to essentially create new behaviors by varying the parameters of the system, without incurring the cost and complexity of hard-coding these behaviors into the system itself. The agents here can only have a single target, which either they are all tracking or none of them are. More interesting behavior for players could be achieved by allowing multiple targets, and having agents select a target individually based on factors such as distance and isolation of the target. Similarly, when switching behavior types between random and flocking, it's either all or none. The script does allow for behavior to be set per agent, but there aren't currently any triggers to cause an individual agent to change behavior type. This was something that I had hoped to achieve, but unfortunately ran out of time. In the current simulation, all agents are able to switch between group and individual behavior, but only when directed to do so by the user. The simulation would be more representative of the type of aggressive AI I was aiming for if agents could intelligently switch between behaviors based on their environment. One aesthetic point I would like to improve is the random agent movement. Currently, at random intervals, agents have a random vector added to their velocity, which is then rescaled. While this produces a good enough result, the movement appears jerky, especially when contrasted with the smooth movement of flocking agents. My project proposal was somewhat optimistic. As I realized I wouldn't be able to achieve everything I'd hoped, I found myself having to choose between hacking in new features or crafting a simpler, higher quality implementation. I decided to simplify the scope of the project while still keeping to its overall goal of implementing aggressive type behavior, and overall I was happy with this decision. I feel the strengths of my project are in the object-oriented design, ability to support a large number of agents, and the user-friendly interface. Thanks for watching.